Hey guys, so now today let's start with a new topic called ordering and the four operations as well as indices and stand form. These are like very short topics and we'll be doing them very quickly. Okay, so let's just move on. So this is the syllabus that we need to cover. First one is basically that we need to talk about the ordering, in which you'll be talking about these kinds of symbols that will be frequently used for your entire syllabus. So you need to be getting ready about that. Second thing is about the four operations that we know. That is, in this we'll be talking about the bid mass, board mass, multiplication, addition, subtraction, division, those things very quickly. The next thing is basically the indices or the exponents or the powers, different names. The workload is only one. So we'll be discussing that up with us. And the last part is basically called as the standard form. So that's a very short segment. So we'll be doing that up very quickly. So let's start. So first one is basically about the ordering quantities and mathematical symbols that is frequently used. First thing is this equal to symbol. You can understand that this is the symbol of equality, which means A and B represent identical point on the real number line. So let's say if I'm having x equal to 2, that means this x value is equals to 2. Okay, the value of this variable is 2. Next thing is basically non-equality, and in that this symbol is used, which means that A is not equal to B. That means, let's say if I'm having 2 and 1, so I can write that 2 is not equal to 1. Okay, so that is the use of this inequality symbol, non-equality symbol. Then the next one is basically the strict inequalities. Just like if I'm having A is greater than B. So what does it mean? That if I'm having a number line, so this A will always lie on the right side of B. Okay, and if it is A is less than B, so this A will always lie on the left side of A, left side of B. Next one is basically the non-strict inequalities. Okay, so what does it mean? That here in this case, when we're talking about the strict inequalities, no value of A was equal to B. But in this case, yes, the value of A can be equal to B also or greater than B also. And for that, they use this symbol. Okay, and for A less than equal to B, so we use this symbol, less than equal to B. So like this. So what does it mean? So if we want to show this thing to you, so if I'm having something like A is less than equal to B, so basically it would mean that the B value will also be getting included when we are talking about the value of A. But in this case, the value of B was not included. That's why we are having the vacant hole over here. And here you can see that the hole is filled up. So that means that we are including the value of B also while just writing down the answers. Now, definition, magnitude, and ordering. So ordering by magnitude requires transformation. So the point is, whenever you're doing the ordering, remember one thing, that you have to bring down everything onto the same form. You can't compare fractions with decimals. So either you have to convert fraction into decimals or decimal into fractions, and then you can compare the things up. Similar with percentages also, roots also. So you have to write down in a simple format, and then you can proceed down with the things. Next thing is like the strategic ordering of fractional and radical formats. Okay, so again, it's very easy. So as I told you that even if they are fractions, decimals, or everything, you need to bring them into a single format. Okay, so just like I can write minus 5 by 4 as minus 1.25, minus 1.3 as minus 1.30, root 2 as 1.41. You can use the calculator over here. 1.41, I can write it simply like this only, and then 0 as 0, and then minus 1 root 1.69 can be written as minus 1.30, and then I can compare the things up and I can get the answers very easily. I hope you must have got it. So you can see that these two are equal to each other. That's why we have written like this. Then the next thing is basically minus 1 by 2.5 will come over here, then 0, then 1.41, and you can see that there's a difference between 1.41 and this root 2 value, because in root 2 it means 1.414, so on. So it's actually non-terminating. Okay, so in this case actually you can see that definitely this value is greater than the below one, that is 1.41. So remember this thing. Now there comes the four operations. Okay, and for that, yes, I'll be telling you about the bid mass or board mass. Okay, so bid mass means bracket. Okay, this I here means indices. People say indices, here it means order, but both of them are actually same. Indices, order, exponents, some people say power. Okay, all are same thing, so don't worry about it. So basically, whenever we are doing any kind of operation, we follow these kind of hierarchy, that we start with the opening of the brackets, then we go for indices, then we go for division, then multiplication, then addition, and then subtraction. Okay, so that's the way we just start. Okay, and we just start from the left to right ranking. Okay, it's not like we start from right to left. No, we have to start left to right. Okay, just like if you are doing these kind of operation, 12 divided by 3 into 2. So you won't be starting like this, that 3 times 2. Okay, 6. No, that's incorrect. You have to start like this from left to right. 12 divided by 3, that is 4. So 4 we have written, and then 4 into 2, that's 8. So 8 is the answer. Like that you have to go. Okay, then fractional transformation and operation. So you also do that. We just did it in the last part only, that this a b by c, this is a mixed fraction, and that can be written as a times c plus b. That's an improper fraction. Okay, like that we can write down the things. And this is a very short example how to solve the things up. So I think you can understand this. You can change into an improper fraction. So now if you are having improper fractions, so you can just subtract the things up to get this. Okay, and then you need to divide it by like this. Okay, there's a thing actually which I can help you. Let's say if I'm having this thing in the numerator part, 23 upon 12 I'm getting while just solving this bracket part of. Okay, particularly I think, yes, yeah, I'll be getting that. And if I'm dividing it by 1 by 3, that means 4 by 3. So the basic method you must be knowing, and many people actually get confused in these kinds of calculations. So just do the primary school mathematics. If you want to change the division to a multiplication sign, what you do? You just reverse the or reciprocate the latter term. So I'll be reciprocating it up and I'll be getting something like this. That will be 23 by 16. And this is the part you can go for. And similarly, you will be getting minus 5, 5 by 2 in the denominator. So you have to divide it like this. So again, you can do the same thing. You don't need to get into difficulties. You can write it like this, like a primary school student. Okay, if anybody just bothers you up, just leave them up. You get the marks and then you just move away. So you can just write it down like this and you'll be getting the answer as 23 by 40. Simple. Just write it down like a primary school student, and it works actually if it comes in a non-calculator based paper. Okay. Now let's talk about indices very quickly. So indices is basically known as powers, order, exponents. Okay, these three are also the names of it. Okay, and the workload is almost the same. Okay, every time. So basically, you need to know something over here that in exponent, if you are having something like this, a to the power n. So this is called the base, and this is called the power, exponent, order, indices, whatever name you want to take. Okay, and there are certain laws that we always follow while doing the calculations when indices are involved. The first one is called the product rule, which says that if I'm having a to the power m into a to the power n, that will give us a to the power m plus n. What does this mean? So if I'm having 2 to the power 3 into 2 to the power 2, so we can write it as 2 to the power 3 plus 2, that is 2 to the power 5. Simple. Next thing is a to the power n divided by a to the power n, that can be written as a to the power m minus n. So what does it mean? So if I'm having 2 to the power 3 divided by 2 to the power 2, I can write it as 2 to the power 3 minus 2, that is 2 to the power 1. Simple. Then the next thing is basically the power of a power rule. If I'm having a to the power m to the power n, so I can write that a to the power m times n. So what does that mean? So if I'm having 2 to the power 3 to the power 2, so I can write it as 2 to the power 3 times 2, that is 2 to the power 6. Simple. Then next thing is zero index identity. So anything to the power 0 where this a can't be equal to 0 is 1. In negative index rule, also we can understand that a to the power minus n is equals to 1 by a to the power n. Okay, and the next thing is basically this fractional power. So if you are having a to the power 1 by n, so you can write it as nth root of a. Okay, like that you can write. Okay, and as I told you, a to the power minus n, when you are having negative exponent, so you can write it as 1 by a to the power n to convert it into positive part. And general fractional law, you should understand that if I'm having a to the power m by n, so I can keep this denominator part inside it only. Okay, but I can keep this numerator part outside, and this is very much helpful. How? Let me explain you. If I'm having 2 to the power, not 2, let's take some other example. If I'm having 16 to the power 3 by 2, so what I can do, I can write it as 16 to the power 1 by 2. You can see this is actually validated by power of a power rule, yes or no? So because this can be written as 1 by 2 into 3, that is 3 by 2. So this both of these things are same. And then this 16 to the power 1 by 2 can be written as square root of 16 to the power 3. And square root of 16 is what? That's 4. So 4 to the power 3, that is 64. Simple. it can be just written like that. Now some examples are there. So the first one is basically I have to just write it into a numerical system. Okay, so if I'm having 7 to the power minus 2, I can write it as 1 by 7 to the power 2, that is 1 by 49. If I'm having 81 to the power 1 by 2, so that means I can write it as square root of 81, that is 9. If I'm having 8 to the power minus 2 by 3, that is also very simple. I can take 8 to the power 1 by 3 inside the bracket, and then I can put minus 2 outside, and 8 to the power 1 by 3, that means it is the cube root of 8. Okay, and cube root of 8 is what? 2. 2 to the power minus 2, it is basically 1 by 2 to the power 2, that is 1 by 4. Simple, easy peasy. Next thing is actually solving the things up. So as you know, 2 to the power minus 3 into 2 to the power 4, so we can use the product rule over here. So I can write it as 2 to the power minus 3 plus 4, that is 2 to the power 1 for the numerator part. And for the denominator part, you can see that it is basically, here you can say power of a power rule. So it will be 2 to the power 6 divided by 2 to the power 4. That will be basically 2 to the power 2. And ultimately it is 2 to the power 1 by 2 to the power 2. So that is ultimately what? 2 to the power 1 minus 2, that is 2 to the power minus 1, or basically it is 1 by 2. Simple. Like that you can go on with the things. Okay, let's move on. Now the last thing actually that you need to understand is basically the standard form. Standard form is a very easy topic. Okay, again, very easy. So the point is, if you're having very big numbers, it's like if you're having 64 0 0 0 0 0 0, like that, you won't be always be writing. So what you will be doing over here, you will be writing like in a compressed form, and that is called the standard form. So you can write the same thing as 6.4 into 10 to the power 7. So both of them are same. So this is basically called as standard form. Okay, and the general formation of standard form is very easy, generalization. So basically it says that we can write any number in the form of a into 10 to the power n, where n represents the number of zeros that we are having, okay, or the number of decimal places we are thinking of, and this a actually basically represents the number, okay, and it should lie between, a should lie, or it should be greater than equal to 1, but always lesser than 10. Remember this thing up. It can't be equal to 10 or greater than 10. It should be lesser than 10, but yeah, it could be 1. Okay, because if I'm having, let's say, 1 into 10 to the power 5, so this is basically 100,000. So that is a validated form. This is a validated form. But we can't write this thing as 10 into 10 to the power 4. This is not a standard form. Okay, so I hope you must have understood. So yeah, the same thing actually. A number is written in standard form if it is expressed exactly as a into 10 to the power n, where a is real scalar bounded by the inequality you can see over here. Okay, and the process again is very simple. You will be starting with the BODMAS. You can just go with that, just like if this kind of calculation is given to you. So this is very easy to do. 4.5 into 10 to the power 7 into 3.0 into 10 to the power minus 3. Just start with this. So if you do the grouping over here, so you can multiply 4.5 into 3, and then the rest part you can put it in another bracket. So 4.5 into 3 will be 13.5, and 10 to the power 7 into 10 to the power minus 3 will be 10 to the power 4. So this is the part from the left hand side. Okay, and then you need to add it up with this 8.2 into 10 to the power 3. So you can add it up with that. Okay, since it is having a 10 to the power 3, so there are two choices. Either just convert this thing to 10 to the power 3, or convert this thing to 10 to the power 4. Okay, so basically here you can see that what they have done, okay, they have tried to convert everything into the standard form. Okay, so now the best thing actually is that if I am having this 8.2 into 10 to the power 3 plus 13.5 into 10 to the power 4. Okay, so what I can do in this case, I can convert maybe this, or maybe this actually in the standard form. Okay, so in this case I can write it as 0.82, not in the standard form, but I need to have the same exponential part. Okay, so in that case it will be helpful for us to do the addition part. Okay, so I can write it like this, and then I can add the things up. So 10 to the power 4 I can take it as common, 13.5 plus 0.82. So that will be how much? That will be 2 over here, and then it becomes 13. So, and then 1 goes over here, then it becomes 14.32. So I can write it like that. And this is not currently in standard form, so I need to convert it into standard form for sure. So what I can do over here, I can divide by 10 and then multiply by 10 over here. Okay, so you can see the final value is same, and then it becomes 1.432 into 10 to the power 5. Like that you can do. It's very simple, again very easy. Okay. Now there are some questions that we'll be solving up so that actually you can get more idea about this chapter. First one is, which of the following statement correctly evaluates the relationship between minus 3 by 4 and minus 0.755? Okay, so definitely if you just convert minus 3 by 4 into decimal for the comparison, so you'll be getting minus 0.75. So it is minus 0.750. This is minus 0.755. So definitely this will be greater. Okay, because that's a negative number, so the smaller magnitude will be greater. Okay, so definitely this will be greater. Okay, evaluate the precise computational value of 16 to the power minus 3 by 4. So again, I think we did the question like this already. So we have to take the fourth root of 16. Now we have already tested this thing up in the last chapter, that 16 to the power 1 by 4, that means we have to take the fourth root of 16 to the power minus 3. Okay, now this 16 can be written as basically what? This can be written as 2 times 2 times 2 times 2 to the power minus 3. So we are having a pair of 4 over here, not a pair, actually a group of 4 over here, 4 elements of the same identity. So we can take that 2 outside and it will become 2 to the power minus 3, that means 1 by 8. So it's very simple again. Okay, so similar to that, actually we can go for these kinds of questions also. Again, not very tough but very easy. Okay, so this question, if you just see here, it says solve for the exact real variable x satisfying the following exponential equations. So what you should do actually over here in these kinds of exponential equation, that you should make the base same, okay, in both the sides. Okay, so if I start with the left side actually LHS, so I can write it as 3 to the power 3 to the power x minus 1, which I can later write it down as 3 to the power 3x minus 3. I think you may have understood. Okay, I'm using the power law over here. And here if you just see, I can write the numerator part as 3 to the power 2 to the power 2x plus 3 divided by 3 to the power x, which can be written as 3 to the power 4x plus 6 divided by 3 to the power x, which is ultimately 3 to the power 3x plus 6. Now what we can do, we can make both the thing and equate it up. Okay, so there's a major defect over here, I think. So basically I'm getting 3 to the power 3x plus 6 on the left hand side, on the right hand side, and 3x to the power 3x minus 3. So now the point is what I'm getting is 3 to the power 3x minus 3 equals to 3 to the power 3x plus 6. Now since base are same, the power should also be same. And in this case, it will be 3 to the 3x minus 3 equals to 3x plus 6. So the point is that this will be having no solution, because this will get cancelled out and minus 3 is not equal to minus 6 and equal to 6. So in this case, it will be having no solution at all. So there won't be any kind of exact real variable for this answer. Okay, you must have understood. Next question is basically with regards to the standard form, that an astrophysical object emits radiation measured at 4.8 into the power 14 watts. A secondary detector captures a fractional component equivalent to 2.5 into 10 to the power minus 4 of the total energy. Compute the precise power intercepted by the detector. Okay, so that's very easy question. You just need to multiply this thing up. So it will be basically what? 2.5 into 10 to the power minus 4 into 4.8 into 10 to the power 14 watts. Okay, so basically if we just see over here, it will become how much? 2.5 into 4.8. I think you can calculate it up. Okay, and you will be getting a specific answer for that. Yeah, so we can just do this thing. I don't have a calculator with me right now, so we can go with that. And this is basically 10 to the power 10 watts. So we can just multiply it up and we will be getting a definite answer. We can multiply by 10 into the power 10 and that will be our answer. So let me just calculate it up basically. It's a very easy thing, so let's do it quickly. So 4.8 into 2.5, that's 12. So it will be 12 into 10 to the power 10 watts. But the point is that it is not in standard form. So we have to write it like this, 1.2 into 10 to the power 11 watts. Simple. Everything is simple, just we have to understand the concepts. Okay, you have to calculate this. Now this thing 125 divided 0.125 can be written as 125 by 1000. Yes or no? Now this to the power minus 2 by 3. Now we can take this 1 by 3 inside, just like how we did it previously also. 125 by 1000 to the power 1 by 3 to the power minus 2. So now if we just take the cube root of it, so it will be basic what? So we can write the interior part as 125 to the power 1 by 3 divided by 1000 to the power 1 by 3 to the power minus 2. So 125 to the power 1 by 3, that means the cube root of 125 is basically 5 and cube root of 1000 is basically 10. So this you will be getting, then you can just simplify it up and you'll be getting 1 by 2 over minus 2, which can be written as 2 to the power 2. That's 4. Answer is 4. The next question is also very easy. So what we can do, again the same thing, 125 to the power by 27 to the power 1 by 3 and minus 2 we can take outside, and then you can do the same thing. You can get the answer. Just post the answer in the comment section. I would love to have a look over that. And similarly this one also. So here it is a negative power. Okay, so we can reciprocate it up, so it will get converted into positive power. Okay, like this you'll be getting, and then actually you can just go with the usual process, that it will be 81 to the power 1 by 4 to the power 3, and this actually, if you just check it out, it is 3 to the power 3, that's 27. Simple questions, nothing much trouble. Okay, again write this as decimal, so I think you can do it. 1 by 2 to the power 4, that is 1 by 16, and then you can just write it in decimal form. Okay, you can do the division part. 16 ones, so 0 point, then still actually you can't divide it, so you will take one more 0, so 16 6 96, and then 4, then 16 2, 32 8, then 16 5. So the answer is 0.0625. Okay, like that only you can go and proceed. Just like for this next question also, you can, it becomes 3 to the power 3 into 10 to the power minus 3 times 3. That means it will become 27 into 10 to the power minus 9. Ultimately it will be 2 points. I have to divide by then 2.7 into 10 to the power minus 8. So it will be looking like this. You can do these question 3 and question 4 by yourself. Very easy questions again. Okay. Now if I proceed with these kinds of numbers, so now writing in ordinary form means you have to write in the basic form. So in these kinds of multiplication or division, so you should just take the A part, actually the part leaving the exponential part. You need to just do the calculation separately for them, and for the rest part you can do it separately, and then you can check it out. What is the answer? So 13.8 into 5.4. What's the answer, dear? Let's check it out. 13.8 times 5.4. That is 74.52. So 74.52 into 10 to the power minus 5, and which you can also write it as 7.452 into 10 to the power minus 4. Simple. So, and yeah, you have to write it in ordinary form. Sorry, it's not in standard form. So that means you have to just write it into the normal form. Okay, just like in the numerical form without any exponential part. So you can write it as 0.00003 zeros, because 7 will be the fourth part. 4 5. Done. Very easy. Yes or no? Yes. And this also you can do it by yourself. Just practice questions. Then find the exact value of this. Try it out once from your side, and then you can just have a look to the solution. So yeah, let's do it. 8 to the power 2 by 3. So that means 8 to the power 1 by 3 to the power 2. And this 49 to the power minus 1 by 2. So again you can take 1 by 2 inside to the power minus 1. 8 to the power 1 by 3, that means cube root of 8. That means 2. 2 square. And square root of 49, that means 7. So ultimately it will be 2 to the power 2, that's 4 divided by 7. 4 by 7. Done. Simple questions actually. This one also is very simple. It may look a little complicated, but it's not at all. So definitely in mathematics you should never get frightened from the questions. Okay, you should just try to solve them up. That's like it is p square equals to x minus y. So 8.5 into 10 to the power 9 minus y, that is 4 into 10 to the power 8 divided by 4 into 10 to the power 8 into 8.5 into 10 to the power 9. So now the point is that this part is not same, so we need to make it same. So I think we can make the first one as 85 into 10 to the power 8 minus 4 into 10 to the power 8 divided by 8.5 times 4. That will be how much? That will be 70 times to 34. Yes or no? So 34 into 10 to the power 17, and this not top part will be 81. 81, yes, 81 into 10 to the power 8 divided by 34 into 10 to the power 17. So 81 by 34, we can again calculate it up. Okay, calculator, 81 divided by 34, that will be 2.38. The answer will be 2.38 into 10 to the power minus 9. Like that, you can proceed. Okay, so it is asking into two singular figures. So you can write it as 2.4 into 10 to the power minus 9. That will be your answer. So hope you must have got it. Okay, so let's move on. Again, very easy kinds of questions actually. You just need to substitute the things over here and you need to take out the answer. If you got any doubts, you can ask me for sure again. Then the B part is also similar to that. Just try it out. It's a very good question actually, which you can try it by yourself and then you can post the answers up. Okay. Again, a very easy segment, but yeah, sometimes you can get some complicated questions on which you need to be very much careful about, and yes, you can proceed with it and you can get some good answers. Fine then. So done. All done from my side. Thank you so much for listening. And yes, in the next part, we'll be dealing with some new segments and we'll be going on and on and on. So just stay tuned. Cheers. Take care. Bye bye.